Thank you. So, my name's Jezen, and as you said, I'm the CTO at a company called Superseed, and we make insurance software. It's not super interesting exactly the industry that we're doing. It's just a big Yesod application. We've been doing this for about 6 years, and in that time, we've tried a few different ideas that were well motivated, but ultimately weren't such a great fit for us. So this talk is about things that we tried, but that we had to roll back on, and sort of why that we did that. Since we're in Poland, I'll say that I met an investor a while ago, and he saw that picture of me, and he, after a conversation, said, "Oh, you're much nicer and friendlier than you look in your photo." That's me smiling in Polish. Okay. So the first idea I want to share with you, or my goal for this talk, is to try and have you challenge some of your own beliefs. So I might say some things that sound a little bit aggressive, but the idea is give it 5 minutes. This is a slogan that I really like, and it comes from an article written by Jason Fried, who is the founder of a company called 37 Signals. They make Basecamp. We try and run our company in the same kind of way as they do. So we try and have a company that doesn't panic about things, and we try and use a lot of first principles thinking. So I really recommend you just type in your favorite search engine, give it 5 minutes. I think the first article that will come up is his one on their blog. I recommend you read that. And it's sort of about when someone says something to you, when you're presented with a new idea, it doesn't benefit you in any way to be so quick with an answer of why that idea is wrong. You know, the easiest thing to do in the world is to reject an idea. It's really hard to adopt new ones. So, the first real regret is Elm. Yeah, but not for the reasons that you might think. I've read a lot of the criticism about Elm on the internet. Probably all of you have. I think you all have. And the criticisms are always something technical about the language, like, oh, it doesn't have type classes, or it doesn't have, it has this weird, so they have like a numeric type, but it doesn't matter. Actually, you can build super effective software with Elm. It's totally fit for purpose. If I were writing a single-page application today, absolutely I would choose Elm. Beautiful language, and it compiles super fast, and the error messages are really friendly. I love it. The reason why I regret picking Elm for parts of our application is because it solved a problem that we didn't really have. So we have a Yesod application. It's a bit like a Ruby on Rails application or a Django application. It's server-side rendered, and we had thought, maybe I had thought, that some parts of our product necessarily need to be really complex on the client side. And of course, you don't want to try and manage complexity with jQuery or even just plain JavaScript. I've written a lot of React, and I don't like it. I think it falls apart. Elm is much, much better for that. And if it were true that we needed to manage lots of complexity on the product, on the client side, then it would be the perfect fit. But actually, the cost of that is really, really high, because your Yesod part, the back end, is one system. Elm is a separate system, right? And you have these two systems that need to communicate with each other. You have data flowing between your back end and your front end. And you have to manage somehow the way these two systems communicate, right? And you can do this manually, which is hard, because you will make mistakes, we will make mistakes. Or we can do something really clever. I bet most people are thinking, but you could just like generate the Elm code from Haskell. generate the types, generate the encoders and decoders. Sure, you could. Now you have 3 systems. You've got more stuff to compile, more stuff that can go wrong, more stuff that makes it harder to upgrade the compiler. The dependency graph is bigger now. You've got a lot more, in our case, template Haskell. So quite a high cost. And professional software development is all about cost. I think it's a poor economic choice. What we should have done instead, and what we are doing now, is to constrain the design of the product. Because actually the users of our product don't really care if it's a single page app. They care that it works. They care that they can enter their information in an ergonomic way and have it presented back to them neatly. And they also care that it's robust. And for it to be robust and performant and accessible, we need to be able to write lots of tests and to try and keep things as simple as possible, which means having fewer things happening at a time. Is the sound okay? Or yeah? Okay, that's enough about The next thing we did, well, actually it predates Elm in our case, was we used event sourcing. Now, event sourcing is a really cool thing. You've all at least heard of, and probably also used, event sourcing. Event sourcing was really in vogue about 10 years ago. Everyone was using event sourcing and CQRS and DDD and all these things. It's actually a super old idea. I think event sourcing actually is about 5,000 years old. Anyone can confirm that? I think it has its like conceptual roots in double entry bookkeeping all the way back to like ancient Mesopotamia, so like 3,000 before Common Era. So it's a good idea, and it's lasted a long, long time. It wouldn't last that long if it were a silly idea. But are you new to this? So event sourcing essentially is that you store what happened over time rather than what the world currently looks like. Okay, so it's a bit like, do you think your bank has a database with the current number of dollars that you own in a cell somewhere? No, they store. You opened an account, then you deposited some money, then you deposited some money, then you withdrew some money, deposit, withdraw. All the events over time, interest accrued, whatever. And then they perform a left fold chronologically over the series of events, right, to derive the current value. Lots of things work this way, right? Git essentially, kind of conceptually works this way. You have a series of diffs over time that are applied to derive the current state of your repository. And it's a great idea, but it's expensive because it's complex, right? If you really care about like the history of the data in your application, your users' data, that's a great way to model that, but it's expensive because when you're implementing a feature, you can't just say, when the form is submitted, it stores a value in a database, or when you visit this page, it just reads something. You have to create a command, issue a command that has to be validated by this aggregate. You have to read from a projection, and event sourcing systems are eventually consistent. Also, right? It's kind of in the name, eventually consistent, which means it's asynchronous, right? And asynchronous is harder than synchronous. If you issue a command, you change something in your system, and you immediately try and read it back, well, there might be a race condition, and there are ways to work around that, but it's hard, right? Which means it's expensive. And if you're running a business, you might never see the benefit of that system. Maybe your business goes bankrupt first, right? Most businesses fail. It's the reality. So we dropped that in favor of just audit tables. That's all the users cared about anyway. It's fine. It's fine. But the interesting thing is that it came from a reasonable place, event sourcing, but we realized too expensive. Postgres. Postgres is brilliant. Does it sound, is there feedback or is it's okay? Can you hear me breathing like Darth Vader? So Postgres is brilliant, but I think at least in our case, it's expensive to test with Postgres if you lock yourself to specifics of the database. If you try and move a lot of logic into the database, then you're sort of beholden to that specific database. You can't have a more like abstract view of how you persist data. And I think it's really nice to be able to abstract that away a bit so that you can do tests in SQLite, perhaps in memory, and constraining yourself to not using all of the more specific, like vendor-specific features of Postgres means you need to think a bit harder about the design of your product and how you model things. There was this talk earlier in the conference yesterday comparing Ruby and Haskell. And it said, well, Haskell has async I/O, Ruby does not. Sure, so, but if you write a program in Ruby, you can still do the things that you would have done in Haskell with async I/O. You just do it a different way, or you have that as a constraint, which you'll find a solution to building your product anyway. So I kind of wish we didn't tie ourselves to a specific database. It's kind of the same thing with should you build your product such that it's really tightly coupled to AWS? Ideally not. So that kind of falls under the same thing. Also, I don't regret investing in NixOS. That's been like a constant over the company's history. We've always used NixOS, and that's allowed us to move our infrastructure from one vendor to another. That's been really, really good. Okay.
Yeah.
Lenses. Complicated. Unnecessarily so. And in our case, we only really flirted with lenses. And the problem with that is that it looks so different that you can't build familiarity with the code that you're reading, so it becomes harder to interact with the bits of the code that are written in lenses because it looks like this whole alien thing, right? It's better, I think, to use fewer bits of the language. You can usually do what you're trying to do with lenses, but without lenses. Although the counterpoint to that is I would still use lenses in a big Elm project, because in Elm you model everything in one big record, like deeply nested usually, and lenses are great for updating things in a deeply nested record. But in our Haskell project, we don't have this problem, therefore we don't need lenses, so again, use fewer things. Do you know what this is? No. This is block element modifier. It's a CSS thing. It's a naming convention, a set of rules that were kind of arbitrarily invented. It's kind of fine, but we didn't need it. And I think the reason why it was chosen was because it's best practice, right? Every front-end developer knows that it's best practice to use block element modifier. Everyone does this, it's industry standard. So yeah, okay, if you don't have other means to scope your style rules to certain components in your page. As it turns out, in our case, we do have other means to get there. Specifically in our case, we generate unique identifiers at runtime and use that to scope our rules to elements. But blindly adopting block element modifier sort of stopped us from thinking from first principles about how to manage our styles so they don't break things, right? This one's evergreen. So I think we prematurely abstracted a whole bunch, and it cost us. Everyone talks about premature optimization. We haven't really struggled with trying to make algorithms faster, but we have struggled with trying to see like patterns really, really early and abstract things out. And we've tried to, like, don't repeat yourself. The other side of that coin is you're now coupling bits of your system to one like complex thing that's harder to work with and it's harder to think about. So it's really easy to draw the wrong abstraction. That's true of any language. Haskell's killer feature is that it's really easy to change stuff over time. Business is all about change. Your system will change. Haskell lets you do that. Not every language does. So be wary of premature abstraction and drawing the wrong abstractions. That's a really hard thing to think about. I can't squeeze that into 30 seconds. Yeah. How are we doing for time? Okay. 5 minutes, okay. Testing is probably the biggest topic for me. Before doing Haskell, I was doing Ruby. And Ruby, you don't have any tools to help you manage the complexity in your project. In Haskell, we do. We have like the best tools, right? The best compiler, bleeding edge compiler, world class, amazing. In Ruby, you've got nothing, which means Rubyists think really hard about designing ways to give themselves this kind of feedback from testing approaches and from tools, in lieu of a real compiler. In Haskell, because we have such good tools, I think there's a culture of not testing properly. Or at least when I've seen people write tests, it's as an afterthought. They'll write their pull request, they'll implement the feature, I'll say, tests? Oh, yeah, there'll be tests. Yeah, I'll put the tests in. And then they put the tests in at the end, and they find, bloody hell, it's hard to write these tests. There's so much boilerplate, I have to set up all the inputs, and it's really complicated. Why? Because you didn't write them first. The whole point of developing with tests first is that they are amazing feedback on the design of your system, right? It's all about test-driven design. It helps against regressions, totally, but that's not really the point. And if your tests are running slowly, it means your design is bad. If it's hard to write your tests, it means your design is bad. And your tests are telling you that. But you have to be a bit more disciplined and write the tests first and allow your tests to tell you that your design should be changed. I can really recommend the old Destroy All Software screencast series by Gary Bernhardt, especially all the videos on testing. He goes into that in really great detail. In terms of performance, you should be able to run 100 tests in 300 milliseconds. If that sounds impossible, then you haven't seen the light of testing. And you need tests to be that fast in order for it to not be painful to continue to maintain your test suite. And if you don't maintain your test suite, the problem gets worse and worse. And then you don't ever do real testing. We didn't invest enough in this, in continuous integration and continuous delivery. And that was a poor economic choice. Really, it just makes sense to try and have the shortest iteration cycle that you can have. And part of that came from taking on too many dependencies, as I mentioned, and also not keeping up to date with GHC version. So we had too many dependencies, which locked us into an old version of GHC, which was slower to compile, and it just, problems compound. And then it's harder over time to make the change to the newer compiler version. So that's something you just have to stay on top on. It just makes business sense. That's it. Questions?
Thanks, Jezen.